Happy to be here presenting on buckling restrained braced frames. Got kind of a full agenda, so let's get started. What we're after is to convey the application of principles of ductile design to buckling restrained braced frames, so we'll cover a few of those principles at the beginning. We're going to cover some of the practical considerations and requirements of designing this system. And then we want you to understand the appropriate applications for this system. So we'll talk about applications, ductile design of structures, the braces themselves, the design of the system around the braces, specification and coordination of braces, some issues regarding connection design, and then a little introduction to some special uses you might consider these braces for. Included in that is the use of the braces with projects that use nonlinear analysis, meaning material nonlinear analysis. Okay, so buckling restrained braces are used quite a bit in low-rise brace frame structures, so a couple of examples shown here. Buildings, 2, 3, 4 stories, even 1 story. I think the one on the left is a 1-story frame here. But they're also used quite a bit in large buildings. So on the left, there's a large office building with a braced frame core consisting of buckling restrained braces and steel wide flange beams and columns. And on the right is a stadium with very large braces for the stadium bowl structure. Buckling restrained braces are also used in retrofits. They have a very good combination of stiffness and energy dissipation. So if the retrofitted building can move a little bit, the buckling restrained braces can dissipate quite a bit of energy. And so you see 3 different applications here on the West Coast of retrofit with buckling restrained braces. Generally, buckling restrained braces are considered wherever special concentrically braced frames are considered, so it's a reasonable alternative. They do offer quite a bit of ductility. As we'll see in a few slides, you can reduce the base shear because of the R factor in the period, and the connection expense tends to be a little bit less. Of course, there are a lot of considerations figuring into cost. It also can be used as an alternative to R=3 concentrically braced frame systems. That would be in seismic design categories B and C, especially in seismic design category C. So in a lot of places, say in areas of Las Vegas, Nevada, where the project ends up in seismic design category C, you could be weighing buckling restrained braced frames against R=3 systems. So here might be your essentially your spectrum computed with an R of 3 using the 2-period spectrum method. So and I've just shown a particular period here, and this is the period coefficient used in the approximate period equation in ASCE 7. So let's say you're considering that, and you might consider a special concentrically braced frame, which has an R factor of 6, so that's twice the R factor, meaning you can cut your design base shear essentially in half if you use that system. It has the same approximate period as the R=3 braced frame. We know that those are approximations, and it's probably just a little bit more flexible because it's designed for less force. The buckling restrained braced frame has an even higher R of 8, and it also, very importantly, has a different coefficient for the approximate period. So at this period that I've shown here, compared to the SCBF, the better R factor and the period elongation gives you a very good reduction in the design base shear. And then, of course, compared to the R=3 system, it's even more dramatic. So you can save a lot of money on the overall system with the buckling restrained braced frame. Now, the braces themselves are going to be more expensive, but there will be savings on the columns, on the beams, and especially on the foundations because of that better R factor and lower design base shear. Also, importantly, the braces can be quite strong, and so you could have fewer plan locations for the braces. If you had a need for 4 braced frame locations with the SCBF, maybe you only need 2 with the Buckland restrained braced frame. And that can be an important thing for negotiating with the architect.